First, apologies to our discussant because we sent him the deck on Friday and the paper on Sunday. So, sorry, Antonin. Where are you? Yes, thank you for your patience. It's still preliminary. It's still fresh. It's still not complete. Mostly, you'll see graphs that look like this, and there's no regression here. So, I just want to sort of caveat this. Fabrizio's here, a postdoc at Laboratory for Information Science. You can ask him all the hard questions. And then Zara Rasuli, RA right now with us, joining the PhD program at MIT. Marco Antonio Avada is a data scientist at our lab, and Kevin, you guys know as well. Okay, so title is AI, the Scientific Frontier, Mapping the Diffusion of AI Across Scientific Disciplines. Could also be hybrid current study of adoption of AI across scientific disciplines from 1950 to 2022. It's nowhere near as good as that paper at all, but certainly inspired by that. So let me just give you an overview of what the findings are. And this graph you'll see over and over again, because that's what we observe when we look at publications across every domain of science except for indigenous studies. AI is becoming ubiquitous in the production of scientific knowledge. There's been a 6-fold increase in the percentage of papers that either develop, apply, or use AI techniques across all scientific disciplines since 1990. Since 1990, the increase in percentage has been 8-fold in the sciences, 6-fold in the social sciences, 4-fold in the humanities, and 2.5-fold in computer science. Computer science already has a big base. There's a noticeable shift in papers from the development of AI to the application of AI. So you see a lot of application of AI. And the use of AI in all scientific fields are rapidly converging to the frontier established in computer science, which was surprising to us. We'll show you some graphs, one graph on that. And then one point that's missing in this transition over, one potential mechanism, we haven't identified all the mechanisms, is co-authorship between computer scientists and disciplines in other fields. Okay, so we'll do the motivation, we'll give you data and methodology, key findings, implications, and next steps. Okay, so of course, we're at a Zvi Griliches conference, and this is of course inspired by this notion of diffusion studies and the diffusion of AI across all scientific fields. And then also the work here about GPTs, not the currently known GPTs, but the OG GPT, general purpose technologies. And the notion that they're pervasive, affect all areas of the economy, they stimulate complementary innovations. But so far, the focus has been on industrial applications. So steam engines and electricity and computers, sort of downstream invention of the GPT and downstream. We're sort of bringing this back saying, if AI is a GPT, then it's actually impacting the production of knowledge itself. So there's a double entendre. And we'll come back to GPTs as GPTs at the end. Of course, AI has been studied well in the field. Lots of folks have looked at it. There's some emerging work by Christina McLaren and others that are positing AI as a general purpose technology. And then also a set of folks thinking about AI through the lens of the science of science studies as well. So what do we have? We have 3.2 million papers across 22 major disciplines. We use the Dimensions database that collects the universe of scientific publications. The one benefit of Dimensions over other publication archives is that it also covers conferences quite well, and computer science publishes mostly in conferences and not in journals. Contains scientific field names, journal names, conference proceedings, and so forth. We downloaded a paper if it had at least one AI term in the title or abstract. We'll walk you through that. And then resulting database is about 3.2 million AI papers, and there's a ANZ-SR classification that we use to define the disciplines. Okay, so one of the questions you'd first ask is like, what the hell is AI anyway? Because it's such a loosey-goosey term in the field itself. We went through a process to come up with about 268 distinctive terms, and we did it through using GPT-4 as well. So there's a lot of this Orbis thing going on. We first came up with our data scientists a list of about 56 AI terms that sort of covered the discipline from our perspective. Then we went to GPT-4 and prompted it to provide 10 closely associated terms for each of the 56 original terms, and we did it like a Monte Carlo, like did it 100 times. The marginal cost to do one more iteration is relatively zero, so we just kept doing it. And the final list of 268 terms allowed us to sort of come to get to terms across in the context of AI. So you can see the 56 C terms: machine learning, decision trees, sentiment analysis, nearest neighbor, k-means, and so on and so forth, support vector machines. And then the example of final AI terms also used as well. And then we did a bunch of robustness tests to make sure that the 268 terms were appropriate. So the first question, of course, is this notion of adoption across scientific fields. And again, I apologize that these graphs are going to look the same over and over again. The number of AI papers across all scientific disciplines. And by the way, our sample cuts off at 2022, so just before the advent of GPT 3.5, which has had a pretty massive impact as well. But you sort of see, you know, classic flat for a long time, then starts to take off. And we see both in terms of the sheer number of papers, but also the percentage of AI papers across all across academic disciplines. These are both using AI as well as developing AI. Is about 6% overall as of the end of our data set. And then you can see this across in humanities, social sciences, mathematics, engineering, computer science, sciences. And this is the sheer number, and then these are the percentage of papers. So you see that even in the humanities, we're approaching about 2.2%. Social sciences, 3%. We'll have some data on econ shortly. Mathematics, computer science, about 40%. Engineering, about 10-ish%. Sciences, about 3.5% overall. And then, yeah, eye chart, but you see what we're trying to get at. So what we see is that the absolute number of AI papers increase over time, and also the percentage. And the top fields are in engineering and natural sciences. And what you see here is sort of across the fields in information and computing sciences, you see sort of the breakdown of these papers over time. And what you see is a sort of a displacement of sort of the more theory side of things into the more machine learning era sort of emerging, and data management and AI all sort of put right into it as well. In economics, we're looking at about 4,500 or so papers in 2022 that came out. And in management, we see basically the operations research groups, the OR groups doing the most work. So certainly when you look at MIT's ORC, they're basically fully gone into AI kind of work as well. In finance and marketing, sort of catching up. Okay, so this is just, again, there's just the raw counts. Again, you see, again, this this sort of these exponential curves sort of showing up. So the other question we wanted to sort of see is like, what's happening in terms of in computer science itself in terms of the generation of knowledge about AI and the adoption of AI in fields. And so what we wanted to understand was this notion of some papers introduce AI concepts and contribute to the field, while some papers apply AI advances to pursue other scientific disciplines. And papers exploiting AI in recent years, what we find is rely heavily on techniques developed at an earlier stage by AI theory papers. And so for this exercise, we just focus on computer science, the field of AI generation, and we look at two methods, basically, to sort of triangulate towards this. One is we look at when the first terms came about, which papers were then invented in. And then secondly, we look at publications in theoretical research journals and conferences. And then what we try to do is see, compared to all other AI papers, how far apart are they from the theoretical papers themselves? So that the field of computer science itself is drifting away from the core theory. And we basically try to measure the semantic distance between each computer science paper and the set of generational and development papers. And then this is normalized distance between each of the papers. And then we try to basically come at this as a cosine distance measure. And so what we see basically is from 1980 up to the end of our data, we see that the cosine distance is basically increasing in computer science compared to the theory papers. So what we tried to do is we looked at the appearance of the terms from our 268 terms for the first time. We looked at it for the first 3 times, and then we try to build a distance metric from that paper to the papers published. And we basically see that the field, the semantic distance, is indicating to us that the computer science itself is moving more towards application. Again, there's many explanations for that. We don't explore that here. You could just see that the commercial opportunities have increased, the application opportunities have increased. You can apply AI to a lot of fields. So these could all be the drivers for this. And then when we just look at, and so what you see, the graphs basically show the same story, which is that the semantic distance is increasing. Again, we sort of identified by 2,000 AI papers, and we see, again, this increasing distance between the bulk of where the field is versus where the theory papers are at. The next thing we wanted to understand was how close were other disciplines to the frontier knowledge in computer science. So you can imagine the computer science is leading the way, inventing new methodologies, and what we were interested in saying is, like, are other fields using those methodologies or not as well? The way, again, of course, the notion of frontier has been talked about quite a bit in the economics of innovation and science literatures. So we have a very rudimentary measure of AI frontier. We create a score. I think we're going to call it alpha or something. I don't know. Yeah. So it's a measure that assesses the recency of AI tools and techniques used in research papers, all research papers, indicating how close a paper is to the cutting edge of AI development. And do we observe convergence over time? And again, we try to basically look at the terms that were when the frontier was invented, and then we see the occurrence of these terms, and then we try to explain and try to normalize this for all fields by computer science. And this is the picture here. And so what you see is, now note again that the baselines are different, right? But what you see is that in the papers, like for example, in language, communications, and culture, that are actually using AI, they're rapidly approaching or even surpassing the frontier of computer science as well. And again, you sort of see this steep convergence post 2010, 11, 12, 13, which is basically sort of Hinton's work on convolutional neural networks emerging and it becoming a general purpose usage across a bunch of fields. Great. Then, of course, one mechanism that we wanted to understand was co-authorship as a potential diffusion mechanism. What we see is the number of co-authored AI papers with computer scientists is again exploding over time. Also looks to be an exponential increase. And in 2022, 1.2% of all non-CS papers written were being co-authored with CS faculty, compared to less than half of that 10 years ago. And so this movement of computer scientists to work with other colleagues may be the mechanism driving the diffusion. It may also explain what may be going on in the computer science field in terms of the usage of the more shift towards application instead of...
Is this the percentage of all papers or the percentage of AI papers?
AI papers in all the fields, yeah. Yeah, absolutely, yeah. So that's, we'll talk a little bit more about how we're trying to get to a more potentially causal explanations for all this stuff, but that's all TBD. Just to sort of bring this back into this double entendre of GPT on GPT. Certainly, these generative pre-trained transformers have achieved sort of surprising and dramatic performance across a range of knowledge domains. What's interesting is that the most advanced models are available for free. So as of last week, GPT 4.0 for Omni has become available for free. And also Microsoft, Satya Nadella has made GPT-4 also available for free through Microsoft Copilot. There are significant efforts right now. I spent a bunch of time at HMS at a research meeting about AI across the frontier of what's happening at the medical school, sort of AI ex-scientists, AI biologists, AI computer scientists, AI physicists, AI historian. Lots of efforts are being done in this space. We're showing both in the work that Fabrizio has led at our lab and then also work out of David Otter's team, showing that GPTs are impacting the cost of cognition for knowledge workers, both showing a decrease in the cost of cognition and problem solving, and potentially increasing as well. And we expect GPTs will make AI as a GPT even more ubiquitous, and could potentially reshape the costs and incentives of scientific production, with interesting implications for burden of knowledge questions as well. I don't know what the experiment would be that we could do on that. It would be kind of fun to think about. And so I think the sort of, as we look ahead, so, in many ways, we're lucky because we stopped our data collection in 2022 before another breakthrough event shows up, which seems to be reshaping science everywhere. So I've been spending some time with the dean of a medical school and the dean of sciences, and they're obsessed. One's an astronomer, one's a researcher. They're obsessed, and they keep saying that this is fundamentally changing how they think the research will get done. Even to the point of some stuff has been published now that shows that you can invent hypotheses, like say for chemistry, and then shift it to a robotics lab that will run the experiment and give you the results and bring it all back to you. So massive automation, again, fields like biology and astronomy, and could potentially streamline segments of the scientific process and offer feedback mechanisms for students and young scholars as well. So what are we trying to do? We're going to try to understand grants, basically try to do a supply and demand analysis, right? How does the demand for AI itself has changed over time by looking at NIH, NSF grants, and looking at the text of the grants and what's been funded, and also private sources, but also the supply, PhD dissertations, to see like what's happening there. And then connected to also to patents as well. And sort of do this patent paper pairing, but in this way. And then also thinking through, because I think a lot about experiments, how we could sort of run some RCTs on the diffusion of AI to industry. That's it. Thank you.
All right, thanks a lot for this very interesting paper, very cool paper that is, as you saw, trying to look at the diffusion of AI within scientific field and especially the adoption of AI by researchers. I'd like to start the discussion by giving it a little bit of background. So we have all seen the dramatic diffusion of AI recently. Everyone is talking about GPT and other generative AI, but also AI more generally. And we are all using probably AI in our work as researchers, and we're right to do so because there's many evidence that shows that when people use AI, and including some evidence from this team of authors, we are faster at doing our task, we are more precise, we are also more creative. So the micro-evidence are clear that there is some potential large effect on the adoption of AI, but the macro effects are less clear. And the reason is that the adoption could be very, very slow, and the take-up could be low, even though those technologies are very easy to adopt. But still, there's not a lot of tasks that are really cost-effective to automate in a way that would make them as efficient or even more efficient as if they were done by a human. And as a result, there is a recent estimation by Acemoglu that shows that we could expect from this automation channel a 0.7 percentage point increase in growth in 10 years, which is very, very small compared to what we would expect. You could get to, it's a bit of pessimistic maybe estimation. Philippe and Simon have a paper that shows that you can get up to 7 percentage point in 10 years, but it's still, not what a GPT would expect from a GPT. And the link with the current paper is that if we want this technology to generate a lot of growth, we need AI to be able to create new ideas, to create new products, and to generate new sectors, not only in computer sciences. And so it's very important to be able to track the diffusion of AI from computer science to other fields. So we can kind of track this, look at the adoption of AI in other disciplines, and then see how it will diffuse more broadly to commercializable applications. Which is, I think, what this paper is essentially about. So they document the significant expansion of AI across all scientific fields, literally all of them. And they also show that it's not just that people are developing new AI model or new way of doing AI. They adopt AI and they use it to do what they are used to do. It literally impacts all fields. And so it's a very interesting scientometrics exercise, and there's many possible developments you can do with this database, and I know you mentioned some of them that looks very interesting. I have a few comments that are essentially ideas for future works. There's something that would be very interesting to know is who is making all those papers. And there's something that looks specific about AI is that a lot of those AI papers are actually made by industries or private companies as opposed to universities. So, there's an estimation of 14% of US publications in AI that are actually done by companies like Google. And if you look at the more impactful article, it's even more than that. The attention is all you need paper, which is at the root of the ChatGPT, has been developed by Google. And in fact, if you look at top research organization in terms of number of AI papers since 2017, you'll find Google and Microsoft in the top 10, along with some usual suspects. If you focus on the highly cited article, this is the top most cited article in AI since 2013, I think, you'll find a lot of them are written by researchers that are Google, OpenAI, Microsoft, and actually much more than what you would find in top US universities or in Chinese universities. So this question, whether this will affect the speed of diffusion, because you can think that those companies are going to keep the technology for themselves. And it's actually not so clear from what we see, because again, OpenAI was built heavily on Google's previous paper. So there is this free diffusion of knowledge from this process of publishing papers. But there is also this second reason why it could not be the case is that AI is very intangible. So there's a lot of the diffusion of AI that goes from open source and open access softwares. And actually, this is coming from the OECD. You see there's this huge increase in the number of requests to GitHub repository, commit to GitHub repository, going to AI-free and open source software. So there is a lot of the diffusion that is coming up outside the private firms. But it would be interesting to see if we could disentangle a bit the two. Okay, let me move to my second comment. So the way you measure the diffusion, so you use keywords to retrieve paper and link the document close there to the frontier, which is very, very interesting, and it seems to be the good way to go. It would be interesting also to use this approach to measure how long it takes to adopt AI by different fields. Could be that some fields, would be more reluctant to change the way the method they are using because they are very deeply rooted in some existing methods. There is this interesting evidence that I found is that if you look at the share of AI papers, so those data are clusters of paper based on the topic they are about. Right? There's like 20,000 clusters. It's coming from the ETO database. And if you look at the correlation between age of the average article in the cluster, so how active the cluster is, and the share of paper that are using AI, there is this clear negative relationship. So the more active and recent field seems to be adopting AI more broadly. And it could be interesting to see, if you could measure it to say more about the potential obstacle you will find in diffusing this technology. You could also, I'm not sure you've done it, but maybe I missed it, use citation to kind of look at the impact of some articles. There's actually a huge heterogeneity in those papers. There is the first paper in my list has 50K Google Scholar sites in 2023. So that's, for me, it was impressive at least. And we could use, the measure there more, looking at the text to look at novelty. Finally, I had a comment on the broader impact that you mentioned at the end on technology beyond academic research. There is this question on whether it will diffuse rapidly or not, and you could use patent paper links. I guess this is what you're planning to do to measure such impact. It would be actually a nice way to define AI patents, because this is also a challenge. If you have your AI paper, which patents are citing those papers? And you could look at the likelihood to be cited in a patent and the use of AI. If you, again, using the same database, I did something very, very rough, but you see that discipline by discipline, there is a correlation that could be positive or negative between the use of AI and the probability to be cited by a patent. And it's actually very big in physics, which could be, good news for us. And maybe physicists are adopting AI much faster than others, and they are developing new ideas with that. Okay, I guess I'm out of time now. So just one last comment very quickly. What can we expect for the future? So you mentioned this burden of knowledge and the way AI could help with that. I think there's something specific with AI is that, as you said, those models are free, very easy to use, but they are, they can help us to do simple tasks in a way. So tasks that are much harder than what they used to be used for, but still they are not replacing the core value that we put in our research. And for that to be very impactful, we need more specific models to be developed. I mentioned the AI biology. There's new models that help doing forecasting with time series. There is theorem solvers in mathematics, but those things are much more complicated to develop, much more complicated to use. So it will take a lot of time for those models to be adopted by the scientific community. And I think it's nice that with your database, you will be able to track that almost in real time. So very cool paper and research agenda. And thanks a lot again for the opportunity.
Thank you.